In this second part of GNSS 102, we will explain the two most common differential GNSS techniques: post-processed GNSS and real-time GNSS. Post-processed differential GNSS provides the highest levels of accuracy and was the original method of precision GNSS operation. Post-processed GNSS is accomplished by operating two or more systems simultaneously and recording all the satellite tracking and position information, then bringing all the data together on a PC and processing the position information after the fact. The most common form of post-processed GNSS is called static GNSS and is just what the name implies, a form of differential GNSS that takes place at fixed, non-moving stations. Static GNSS is used to compute very high accuracy geodetic reference points or precision survey control points. Because the units remain fixed on a target point for several minutes, the position is computed with a great deal of data, and positional accuracies can be accomplished at only a few millimeters. With post-processed GNSS, the data from multiple field units is taken back to the office and combined on a computer. Special post-processing software is used to merge and align the GNSS data from several receivers according to the highly accurate timestamps, or epochs, on each and every measurement in the field. The data taken at matching times can be processed to calculate an accurate baseline vector, or differential position, between two or more receivers. In this way, we can extend known three-dimensional coordinate information from a control point to a new reference point located anywhere on our project site. As GNSS measurement techniques improved, additional post-process data methods were developed. The next was post-process kinematic. In this case, the term kinematic means moving as opposed to fixed locations as with post-process static operations. In this method, one unit remains fixed, the base, while the other unit, the rover, moves around, constantly taking data and tagging only certain locations to be measured. Each unit stores all the GNSS signal and position information, and just like with static operation, all the data is brought together on a PC to process the position information in the office. This technique was typically used to collect existing ground information or topography of a given area. As GNSS technology progressed, smaller and lighter units, sometimes even handheld, were developed to perform mapping for Geographic Information Systems, or GIS. These systems lacked the high accuracy of the post-process systems, but could provide real-time coordinate accuracies in the field of just a few feet. By receiving some kind of differential correction message, this type of system is referred to as real-time GNSS. The differential error correction for these types of units was provided by two primary sources: either a ground-based correction system called Continuously Operating Reference Station, provided free by the U.S. government, or fee-based satellite correction services offered by private companies. Eventually, the government provided a free satellite-based correction service called WAAS, the Wide Area Augmentation System. Any of these services could provide radio-based correction to GNSS mapping systems that could receive the signal. While this may not be good enough for precision construction, surveying, or machine control, it is certainly acceptable for GIS mapping or precise navigation. Finally, in the mid-1990s, with the ability to connect two precision GNSS receivers on the same job site with a radio data link or modem, the most beneficial differential GNSS technique was introduced: real-time kinematic, or RTK. With a local fixed base station on a job site continually transmitting the GNSS correction information to one or more local rover systems over a fixed communications link, we are able to achieve not only real-time position information, but local real-time correction that could compute our position down to a fraction of an inch. This method does require a minimum of 5 available satellites rather than 4, but this is typically not a problem, especially with multi-constellation GNSS systems. RTK provides high accuracy like post-processed kinematic, But since the connection is local and live, it gives you precise coordinate information in real time, right there on the job site, without having to go back and process a bunch of data. Suddenly, RTK opened up all kinds of GNSS applications on a job site. Not only could you accurately measure your location on the site in real time and collect information, but you could compare the real-time position to site design files to stake out points, lines, or measure cut and fill values on a construction site. Using RTK GNSS for precise three-dimensional positioning does have a minor limitation in that, because all of the satellites are overhead, the receiver cannot resolve vertical positions as accurately as the horizontal. Typically, where RTK provides horizontal accuracy within a centimeter, the vertical accuracy is within approximately 2 centimeters. Today, RTK GNSS is the most common form of precision GNSS technique used. RTK GNSS is the heart of a single operator collecting topography information or staking construction points, and is the key to machine automation in construction and agriculture.